Okay, so we're going to look at now how to modify this, expand it, to do more with it. And in order to do so, we're going to also learn some kind of coding principles to help us out here. Some C++ things. So before we do so, let's just remember that as we go over this, the kind of basic Arduino structure is that you have this setup function. And you see here this comment here that says it runs once when you press reset or when you power the board. And then we have the loop function that continues to go cycle through. It goes down line by line and then starts from the beginning and goes again over and over indefinitely until power is disconnected, essentially. And then in this case, we have inside of here we're calling additional functions, and so this function here, digital write, executes code that causes pin 13 here to switch to high. And then we have this delay function here that's going to cause it to everything to go to freeze for 2000 milliseconds, and then we'll go to the digital write low and so on and cycle. Okay, and so let's say that we wanted to use more LEDs. Okay, well, in order to do so, we have to repeat a lot of these steps, right? So I'm going to go ahead and take all these lines here. I'm going to copy them, Control C or Command C to copy, Command V, Control V to paste. Okay, and now we have this happening twice. Well, I'm going to change this to different pins. Maybe we use pin 10 here. Okay, so we have pin 10 and pin 13. And now if we execute this code, we go through it line by line. Pin 13 is going to turn on. Then everything's going to stop for 2 seconds. Then pin 13 is going to turn off. And everything's going to stop for 2 seconds. And then pin 10 is going to turn on. Then everything stops for 2 seconds, then pin 10 turns off, then it stops for 2 seconds. Okay, so we're going to switch over to the simulator here, so and kind of see what this looks like. So we have this Tinkercad Circuits has an Arduino simulator in it, and so I've gone ahead and pasted the code in here. And so you can see here's the code that we just wrote, and I've got the circuit wired up, so we have an LED connected. So the resistor is going to ground, and then the anode is going to pin 13, and then we have a yellow one here with the anode going to pin 10. Okay, and so we're going to press to start the simulation, and what we should see is that it turns on, it waits, it turns off, and then waits, and then this one's going to turn on, and then wait, and then turn off, and then wait. Alright, is it working? Kind of. That yellow one for some reason looks really dim. Oh, actually, it's a really good thing we didn't talk about that. So you'll notice that there's one line we didn't repeat, and this is actually something I wanted to talk about, and I forgot to talk about it, and this is a good way to address it. So we can see pin 1, or the first LED shining really bright. That second one is pretty dim, and the reason why is we didn't set it as an output. And so some kind of internal stuff is going on when you configure the input or the output. And I think it has to do with internal resistors. I'm not sure exactly what's going on here, but we need to set pin 10 as an output as well, and we need to do this for any LEDs we use. Otherwise we're not going to be able to really see them, so we're not going to get, probably it's not getting all the way to 5 volts. When we change, the voltage is switching, but it's switching to like a lower value. And so we go ahead and start our simulation here. With the yellow, it turns off, and the yellow one turns on there, and there we go. And so they're switching on and off. Now you can see there's kind of a gap between when they're on and off, and the reason why is because in our code here, we turn the one off, and then we wait for 2 seconds before we turn the next one on. And so it might look better if we remove that delay here, so that we turn the LED connected to pin 13 off at the same time that we turn the other one on, and we can do the same thing after this line here, so that we turn this to low at the same time we loop around and turn that one to high. So if we start this simulation, we can see they're alternating being on and off now, and that kind of solved that problem for us. Okay, and so the things to remember here though is that for every one that we every time we want to connect and control an LED, we have to set it as an output. Okay, and then coming to here, you'll see that we were able to make it look like they're switching, like alternating, by removing some of those delays. Okay, and so you only want to delay in places where you want to wait. Where you want things to happen at the same time, we put them right next to each other. So like if we wanted pins 10 and 13 to turn on at the same time, we could put this one right here, for example, and then we could put move this delay down to here, and so now we have and all my tabs got all messed up, but so we have the two of these turning on with no delay between them, so they're turning on at the same time. These two turning off with no delay between them, so they're turning off at the same time. And then we run that one, and we can see them blinking on and off together. Okay. A couple more things to talk about here, so let me go ahead and add this in. And then if we were going to eventually when we're done with this video, you're gonna do this with 6 LEDs and have 6 LEDs going at once. And so we have to get to a point where we want to be really careful about not losing track of everything going on. And so we have a pin 10 here and a pin 10 here and here. And let's say that, well, this LED that's on pin 10, well, let's say I want to move it to pin 9. We'll have to go through here, and all the places I have pin 10, I have to change it to 9. Right, and maybe it's just in one place, maybe it's in like 20 different places, and so I have to go through and find every time that occurs and change it. Okay, which can the problem there is one, that's kind of a waste of time that we have to go through and do that for every single place that we see the 10 or the 9 that we want to change it. But also, one thing that you want to be really careful about is you can also make a mistake. And so if we're trying to find all the places where it has the 9 and change that to a 10, for example, if I accidentally miss something, and so I got these two but not that one, well, then that's not going to do what I want, and that's going to cause a problem for me potentially if I missed one on accident. And the chances are that you'll miss something at some point without realizing it. And so one of the tools that we have to avoid that is to basically make a placeholder to store that information. And so we're going to create a variable, and we can name it whatever we want. But a variable is just a placeholder for information. So we'll start with the letter x, because x is something we're used to seeing as a variable. So we'll say x equals 10, and we have the semicolon there, and we use that as a placeholder for all of the places that we have the 10. Just like that. Okay, now if I want to change that to pin 9, I can change that to a 9, and now when this program runs, it's going to fill that x with the 9 when it gets to here. When it gets to here, it's going to fill that with a 9 there, and so on down there. And so that allows me to make changes very easily just by changing this one number here instead of the 20 or however many times that it appears down here. Okay, now if we go ahead and compile this, we're going to actually get an error. Okay, and so we've compiled it. We're compiling instead of running it since I don't have a board connected right now. And you see it says x does not name a type. And if we look down here, it says 5.1 x does not name a type, x equals 9, and then semicolon. And so we didn't tell the compiler what type of variable x is. And so what we have to do is we have to be very specific for C++ or C to tell it what data type we're using here. And so in this case, 9 is going to be an integer. And sometimes you might use a float, sometimes you might use a char or a character, and in this case we're using an integer. Now there's some languages that are what we call dynamically typed, and they can kind of self-detect what data type it is, but C and C++ are what we call statically typed, which means we have to tell it what data type it is. And it might seem like a lot of work, and you might wonder, like, why do we have to do that? Why can't it just tell it? Why can't it just decide for us what it is? And the reason why is because there's actually some benefits to having a statically typed language, because then we can actually, for example, we can take a number that's formatted as an integer and do all kinds of integer math with it and then tell it to be something else. And that's a really powerful tool. But I'll just show you an example here about why it's important, and that will be it for now. And if you did get into a field related to like embedded systems or working with C or C++, you'd learn more about this kind of idea of static typing and why it can be beneficial. Alright, so I'm going to run this simulation code here to kind of show you why this matters. And so I've created a variable here that's storing the letter A in it, and I've called it a character or a char. And so what we're going to do is I'm doing some stuff here that we haven't learned about yet. We'll learn more about later. But we're going to print out this value X here, format as how we did it here, right? We called it a char. But we're also going to now print it out, format it as an integer. Okay, and then what I've done here is what's called a cast, where I've told the compiler to reinterpret this as an integer instead of a character, and so we can see what happens. Okay, so we start the simulation, and if I open up the serial monitor here, you could see that the value A formatted as a char is an uppercase A, but the value A formatted as an int is the number 65. Okay, and there's actually kind of a lot going on here, and really there's a number formatting called ASCII, and the value for the numeric value for the letter A is 65, and so the number 65 and the character A actually get encoded the same way when it's stored as a variable in C and C++, and then we have some kind of tag goes with that variable that tells it how to interpret it, whether it's a character or an integer. And this is just one example. There's actually a lot more powerful things you can do with this that are you'd have to kind of learn a lot more about object-based programming and stuff like that in order to really get into that stuff. But the takeaway here is that we have to actually tell the compiler what we want that variable to be. So we name it as a type, and we verify it, and then everything works now the way we would expect. There's no errors here. Okay, now instead of using the letter X, we should actually use something that is a little bit better at explaining what we're trying to do here. Now, when you call name a variable, you can really name it whatever you want. You can name it after your brother or your pet, or a friend, or a street, or a town, or a favorite character in a TV show or a movie or whatever, or a book. But the best practice is to use something that kind of explains what its purpose is. So we'll call this one LED2. Okay, and generally there's some rules for how we type variables and stuff like that, and we'll kind of get into that stuff later. We won't worry about it for now. So we have LED1 will be 13, LED2 will be 10, if I can type it here. And so then I'm going to go ahead and put these into these spots here, which is now going to allow us to make easy changes, right? And there's like a find and replace feature which could save us some time, but we're going to do this. Okay? Now if I want to change LED1 to be connected to pin 8, for example, I can just change this to 8, and that will carry to all the places that I typed the variable LED1. Now the thing that we want to be very careful about is that anywhere we see LED1, we remember that doesn't mean anything about the LED. Okay, that's just a tool that I've created to hold the number 8 or 13 or whatever. So this variable is a tool that I've created to store that number 8 in it. It doesn't have anything to do with the actual LED except that I have the intent of connecting that to an LED, and I'm broadcasting or sharing or expressing that intent by naming this variable after the LED I'm connecting to it. And so this allows me to be a little more flexible, be able to change things more easily. And now when I start to expand this code for additional LEDs, I can name one LED3, I can name one LED4, and so on, and then I don't have to worry about putting all the pins down here. Okay? Also, anytime we see, in our functions down here and down here, a number, like we have the number 2000 here, anytime we see a whole number like this, this is often called like a magic number, where we just have a number sticking there somewhere. It's not a best practice. We want to try to avoid magic numbers, and so any place we can replace a number that pops up down here, up here, with a variable, we want to try to do that. And so we're going to make another one called delay time, and you can see that I capitalized the second word there. and we'll set that to be 2000 since I'm using the same value for all of those. And I'll go ahead and replace it in all of these spots. And now I've gotten rid of all my magic numbers here, and I've got this code that will perform this blinking sketch. I might get rid of the one right here and the one right here from before. Okay, and we'll go ahead and test it to see how it works. Okay, so one thing we'll do is, since we had changed pin 8 or pin 10 to be pin 8, we'll go ahead and move that one. So I'm going to take this guy right here and move this to pin 8. Okay, and now I'm going to start my simulation, and we have them alternating, the one on, the other one on, going back and forth. Except this time there's no magic numbers. I'm using all these variables up here so I can easily make changes. So let's make the delay faster, like that, and then you can see now they're blinking faster. Okay, so one last thing I want to share just before we wrap it up is just some kind of a reminder about how some of the formatting here works, and also some tools for kind of catching your mistakes and finding bugs. Okay, so a function definition, you can see, has a beginning and an ending brace. Okay, and if I don't have the ending brace there, I'm going to get an error because that function has to end before this function can begin. And so this function has to have an ending before this function can start. If I run this code, it's going to give me an error that's kind of confusing. Okay, and so that's why I'm showing you this, because it doesn't make sense. It says a function definition is not allowed here. So it's saying I can't have this function definition here. Well, the reason why is because it's currently inside of this setup function. So I have to make sure that setup function ends before I can define a new function. And so one thing that I notice a lot is it's really easy to leave out a closing bracket or starting bracket just on accident. And when we do that, or if we accidentally delete one, it can the debug messages we get can be kind of confusing. Okay, and so just have to be careful about that. One thing to note is oftentimes when you see an error like that where it's pointing out at line 16, sometimes the error's occurring before that line. And so the same thing, like if I forgot to put a semicolon here, well, the error is going to show up as line 13 or 16, and so I'm looking to see in front of those things what's missing. Okay, and so here it says the line 13, I'm getting the error. Well, that means something might be missing before it. In this case, it's the semicolon. Also, another thing, these variables are case sensitive. So I put the capital T here. If I make a spelling mistake or use the lowercase t, or put like an accidentally put an S instead of a D, or like a T or an O or something like this, when I verify it, I'm going to get errors for both of those things because it's looking for an exact match. Okay, and so when we see this, you can see we're getting an error there, and if you also look, we're getting an error from the delay time as well. So it says delay time was not declared. Well, and the reason why is because when I declared delay time, I had it with a capital T there, and so I need to go back and put that capital T in. Same thing here, got to make that to be LED1. And so it's looking to see that it's an exact match for the variable names. Now I compile that and it's all good. There's no mistakes. Okay, so hopefully this is kind of enough to get you started on the next part of this activity. So you're going to be building, basically you're going to be blinking 6 LEDs and making some kind of like pattern of blinks and stuff like that. So have some fun with it. Hopefully this is a good kind of starting point for you, and if you have any questions about it, please let me know.